Good evening, all. I will start the lecture by in 10 minutes, as only one student has joined. I will wait for other, and then I will start the lecture at 6:10 p.m. So please tell me that if there is a lot of noise now, or is it fine? I will repeat it once again. Okay. So polysaccharides are complex carbohydrates made up of many monosaccharides joined together by glycosidic linkages. So this is a typical diagram of monosaccharides. When we combine these two monosaccharides, then we get is a disaccharide. And this disaccharide is joined by a bond, which you can see here. It is known as glycosidic bond. So when this is the zoom image of this one only. So if you see clear, particularly here, it is CO and C. So it is also known as COC linkage bond. So also known as ether bond. Just sorry for the disturbance. Just wait a minute. Wait, actually there was an important call. So yes. So this bond, which is a COC bond, is also known as ether bond. So this ether bond and monosaccharides, a combination of monosaccharides, collectively forms polysaccharides. So cellulose is a type of polysaccharides. So this is a typical structure of cellulose. Here you can see that it looks like a type of sugar only, sucrose. Just the difference is that sucrose has two. That's why it is known as disaccharide. It has two monosaccharides, so it is known as disaccharide. But cellulose has N. N can be any number greater than 100,000 or 10,000. So it is a polymer. So unlike sucrose, it is a polysaccharide. But lignin, on the other hand, is different. It is a type of phenol. It is rich in hydroxyls, and it is also known as polyphenols. And protein, on the other hand, is defined by NH2, which is also known as amine, and COOH, also known as carboxylic acids. So protein has amine and carboxylic acid, lignin has phenols, and cellulose has polysaccharide in it. So cellulose is only the thing in that option which is known as polysaccharide. I hope that you have understand this, the difference between polysaccharide, polyphenols, and proteins. Now let's move on to the next question. Hemicellulose in lignocellulosic biomass is composed of. So in previous slides you have seen, previous weeks also you have might have studied that hemicellulose is made up of two kinds of sugars, pentoses and hexoses. So hemicellulose is a combination of these two, but there is also an acetyl group in them. So that's why the answer is all of the above. So pentose and hexose both are sugars that are found in different things and different types of hemicelluloses. And hemicellulose has different ratios of these pentose and hexose. If we extract pentose and hexoses from different types of hemicellulose, such as leaves or wood or any other stem, we will get different ratios. There is no fixed ratio of pentose and hexose. And what are these pentose and hexose? Pentose is nothing but a type of carbohydrate which has five carbons in it, and hexose is that which has six parts in it. And these are the building block of bigger things, such as pentose make up most of the DNA. Pentose is responsible for most of the DNA of the plant, whereas hexose is responsible for the fruit or honey in the plants. And if we look at the chemical structure, So typical hemicellulose looks like this, and it is made up of pentose and hexose, and it is also connected via acetyl groups on the ends. So the answer what that was that hemicellulose is made up of pentoses, hexoses, and acetyl group. Now let's come to the third question of the assignment for 2021. The main reaction during acid treatment is. So first of all, what is acid treatment? Acid treatment is nothing but it is a method to separate hemicellulose and lignin from cellulose. When we have any type of biomass, particularly lignocellulosic biomass, so it has three things: lignin, cellulose, and hemicellulose. So, in order to separate these three things from the biomass, we need to do some kind of treatment. There are various types of treatment, such as acid pre-treatment, alkaline pre-treatment, organosol, water treatment, hydrothermal. There are numerous types of treatment. So, this question involves the discussion on acid treatment. So, among these options, the correct answer is that acid pretreatment involves hydrolysis of hemicellulose. So hydrolysis of hemicellulose means that hemicellulose is hydrolyzed, that addition of water is done. So addition of water is done in the hemicellulose so that we could hydrolyze it and so that it forms soluble sugars. And the second step is condensation and precipitation of solubilized lignin. So in this also lignin gets transformed into some soluble phenolic lignin. So lignin gets converted into soluble phenolic lignin, and then we condense it and precipitate it so that we could separate lignin out of lignocellulosic biomass. So I will explain this in detail in the next slides, and there are many questions related to this. So the discussion will be done in other slides also. So as we know that lignocellulosic biomass is a complex biomass metal that is composed of lignin, cellulose, and hemicellulose. So acid pre-treatment particularly is done to break the cellulose. We have to break the cellulose, and this is done by hydrolyzing it. We first hydrolyze the cellulose and then convert it into soluble sugars. As I have explained, that we need to hydrolyze is nothing but it is like addition of water. But this is not done easily. We cannot just add water. We have to do it in the presence of some other chemicals. So in case of acid pre-treatment, we use acids, and mostly it is done by H2SO4 or sulfuric acid. So acid hydrolysis of hemicellulose is a process in which we hydrolyze hemicellulose in the presence of H2SO4 just to make it into soluble sugars. And on the other hand, lignin is converted into soluble phenolic compounds. And lignin is also chemically changed. We change the structure of lignin. It is converted into soluble phenolic compounds, and then we do the condensation and precipitation, forming a complex network with lignin, and we get the lignin separated from the lignocellulosic biomass. So this is a overview of acid pre-treatment in simpler terms. And here is a graphical representation of what I have explained. So when we take a lignocellulosic biomass, it has three things: cellulose, hemicellulose, and lignin. The hydrolysis involves acid treatment involves the reaction with H2SO4, and thus we can do hydrolysis, and celluloses are converted into small monomer unit. These are small monomer unit which are hexoses, and hemicellulose is converted into hexoses and pentoses. So and these both hexoses and pentoses are water soluble. So in this way we can convert lignocellulosic biomass, a very big molecule, into small molecule. It is nothing but to convert a big molecule into small molecule. And on the other hand, lignins are converted into phenols. So these hexoses of pentoses can be further fermented for creating biofuel, or can be converted to furans and other various types of products as per the requirement. So last question was about acid pretreatment. Now this question involves alkali pretreatment. So first of all, alkali pretreatment results in. So first of all, what is alkali? Alkali is the opposite of acids. Acids are acids have a pH of less than 7, and alkalis have pH greater than 7. So alkali, just as we do the acid pretreatment, we perform alkali pretreatment also. So the question was, alkali pretreatment results in structural alteration of lignin, partial decrystallization of cellulose, partial solubilization of, or all of the above. So the answer of this was all of the above. I will explain this in the next slide. So during alkali pretreatment, we use a very strong base or strong alkali such as sodium hydroxide. In acid pretreatment, we used H2SO4. In alkali pretreatment, we use NaOH, mostly NaOH, and sometimes we also use ammonium hydroxide, which is NH4OH. So, alkali pretreatment is used to break down the lignin structure. We will break down the lignin structure by breaking the ester bonds and cleaving the side chain. So, lignin also has some types of ester linkages in it. It is represented as COOR. So this bond is broken by the alkali, and and thus the lignin is broken down. This also this alkali pretreatment also makes the hemicellulose more soluble in water, and thus the solubilized hemicellulose can be separated from the solid residue after washing or filtration techniques. This also leads to partial swelling of cellulose fiber and exposure to cellulose surface, making it more accessible for hydrolysis. So, alkali also is a similar method, just like acid pretreatment. Just the difference is that we use sodium hydroxide instead of H2SO4. Here is some block diagram about it. So if we take a biomass which is rich in lignocellulose and we give NOH as a pre-treatment, we provide high alkali solution to it. Then the NOH, this we can get hemicellulose and cellulose separately. But in this also we can the alkaline material, the alkaline solution, we can utilize it and recycle it again. So we will send this highly concentrated NOS solution for filtration. But this pre-treated biomass, we will send it for washing because it has very high amount of NOH. So we need to remove this high amount of NOH. So we wash it with water until the pH comes near to 7. So we do the washing, and during this washing, water and NOH gets combined. So the concentration of NOH comes lower. So this low concentration NOH is also then sent for filtration, and then we can filter it and then use it again. So we can there's a type of uh, reduction of wastage. We can reduce the NOH wastage and recycle it and consume it again for the pre-treatment. After this washed biomass, we can separate we get the separated lignin cellulose and hemicellulose as we get in acid pre-treatment. So just like the acid pre-treatment and alkaline pre-treatment, we have other pre-treatment type which is known as organosol pre-treatment or organosol treatment. So the next question is the organosol treatment of lignocellulosic material with the use of alcohol leads to. So first of all, what is organosol? Organosol is a short of organic solvents. So mostly, as we have seen that we have used NaOH in alkaline, H2SO4 in acid. Now we have another method which is organosol. In this we use organic solvents such as alcohol, and we can use ethanol, methanol, acetone, and acetic acid. There are various types of organic solvents which we can utilize. So the question was that what organosol treatment leads to what? Lignin removal, solubilization of hemicellulose, both in B and none of the above. So the answer, you can guess that the past three questions were also about these two things, that lignin removal and solubilization of hemicellulose. Whatever we are doing, whatever type of pre-treatment we are doing, every pre-treatment involves the removal of lignin and solubilization of hemicellulose. We need to remove the lignin from biomass. If we have a biomass, we need to remove the lignin out. We need, because it acts as a barrier towards the further processing. And the second thing which we need is to solubilize hemicellulose. When we solubilize the hemicellulose, we can get lower molecular weight sugars, and then these can be again fermented for the biofuel production. So every type of pre-treatment you will study will have only these two things, that you are removing the lignin or solubilizing the hemicellulose. So this method also involves same things. So how it is done? How it is different than acid pre-treatment and alkaline pre-treatment? So this process begins by placing the biomass in a mixture of organic solvent and water at high temperature and pressure. So just assume, if we want to do this in a lab scale method, we will just use a heater, and we will use a reactor in which we will put some biomass and add some organic solvents in it. We will apply the heat to this organic solvent, the biomass and the organic solvent, and this will be done in the pressure. As the organic solvent will, the temperature of organic solvent will rise, it will increase the internal pressure inside this reactor. So it happens at high temperature and high pressure. So during this high temperature and high pressure, the organic solvents goes inside this biomass and breaks it from the inside. So the organic solvents used in solvent treatment can vary. Commonly, solvents include ethanol, methanol, acetone, and ethylene glycol. These are the most common. But nowadays, acetic acids are also being used in other kinds of acids because they reduce the time of this organosol treatment. So these solvents have the ability to penetrate the biomass and dissolve lignin. So they go inside the biomass, they dissolve the lignin, which is the barrier towards the accessing the cellulose. So main thing which it does is it dissolves the lignin, and further it will also dissolve the hemicellulose. So treatment is an effective method for removing lignin and solubilizing hemicellulose from cellulosic biomass, making it a suitable feedstock for bio-based products. So in this case, if we have a biomass, we will use different types of organic solvents such as ethanol or acetone or acetic acid or any other thing. And we also use some kind of catalyst just to increase the time, because and increase the time and reduce the pressure, because these reactions happen very good at very high pressure, but to perform at a low pressure also we can use some kinds of catalyst. So what we get is we will get a cellulosic pulp, and we will also get we can also precipitate the lignin and get solidified lignin, and the hemicellulose we get in a soluble form. Like in previous, we have we get the hemicellulose in soluble form, and we get the lignin particles after precipitation, and thus we have separated these two from the cellulosic pulp. Now let's move on to the next question, which is also a type of different pre-treatment. So microwave radiation in combination with DES pre-treatment. So this question involves rotates around DES pre-treatment. So what is DES pre-treatment? What is DES first of all? So DES means deep eutectic solvents. Deep eutectic solvents. So in this, what we do is we mix two solvents, solvent 1 and solvent 2, in some particular ratio. We will mix them to get a new solvent, a mixture of solvent, which will have a lower melting point than lower boiling and melting point than 1 and 2. So this is known as DES. So combination of solvents are also used for pre-treatment. When these type of combination are used, we call it DES pre-treatment. So the purpose of this is also the same. We have to remove the lignin and hemicellulose. But the DES pre-treatment is not very much effective. But we can make it effective just by combining microwave radiation. If we give microwave radiation, then the efficiency of the pre-treatment increases very rapidly. So what is the reason behind this increased efficiency? Just by adding microwave radiation we get good efficiency. So is it due to increasing the molecular polarity, decreasing the molecular polarity, increasing the process time, or none of the above? So the correct answer is that increasing the molecular polarity. So what does this molecular polarity means? What do we get from this word molecular polarity? It means nothing but it gives some type of, you can assume that it gives some type of charge to the DES. So the EES will become highly polar, means some type of charge will be given to it. So uh, this will react rapidly. The charged DES will react with the lignin and hemicellulose very rapidly. So this charge is very important, and this charge is provided by microwave radiation. There is one more addition to this, that when we apply the microwave radiation, the water molecules trapped inside the lignocellulosic biomass, they vibrate at a very high frequency, and then they leave the biomass very rapidly. So microwave also increase the uh, efficiency by decreasing the time. It decreased the poly. So this option was wrong because it actually decreased the processing time by removing the water very rapidly. So the answer was increasing the molecular polarity of DES. So I will repeat this again in the slide. DES stands for dibutyric solvent. It is a type of solvent that is made by combining two or more components. We combine two or more components in a very certain ratio to form a liquid with lower melting point than each individual component. And when we apply microwave, the polarity of DES increase. That is charge of DES increase, which makes this DES more interactable to the biomass. So DES will interact more because it has high charge. It will get attracted towards the biomass, and then will interact with it and then change the structure of lignin and hemicellulose very rapidly. So now let's move on to the seventh question. The effectiveness of the alkaline pretreatment with hydrogen peroxide depends upon. So now we have seen that the alkaline pre-treatment is a method to remove the lignin and dissolve the hemicellulose. But what will happen if we add some kind of hydrogen peroxide, a new chemical, hydrogen peroxide? So the question was the amount of biomass to be treatment, temperature, concentration of peroxide. So which will be the reason which will increase the effectiveness? So answer for this is all above. See, hydrogen peroxide also will act as a catalyst, but not as a, but it fasten the reactions. So the higher the hydrogen peroxide, higher the reaction rate, and also temperature. If we increase the temperature, reaction rates will increase, and the amount of biomass to be treated. The thing about this is that if we use more biomass, our efficiency will increase because the higher the biomass, higher the surface area of biomass, and higher the surface area of biomass, then higher the reaction on the surface. So the amount of biomass used is important because its effect on the surface area and contact between the biomass. If there is insufficient biomass, if we have very less amount of biomass, the reaction may not complete or may not occur at all. So we need a particular amount of biomass. We cannot do it in less quantity. So a high amount of biomass is also necessary when we do hydrogen peroxides, when we use hydrogen peroxide. Also, less amount, if there is less amount of biomass and high amount of hydrogen peroxide, it can degrade the biomass also. And secondly, the temperature and concentration of hydrogen peroxide and base affect the rate of chemical reaction. See, if we increase the temperature and concentration, then chemical reaction rates will also increase. So higher the temperature, higher the concentration, then higher the reaction rates. Now let's move on to the eighth question. Acid pre-treatment is used for the removal of. So for now, you know that acid pretreatment is used for the removal of sorry, actually the NPTEL is showing the answer as hemicellulose, that it is used for the removal of hemicellulose, but it is used to make hemicellulose soluble and remove lignin. So the NPTEL answer might not be correct for the 2021 question, as we solubilize the hemicellulose to make it sugars and we remove the lignins. During this acid pretreatment, there is also one reaction that when we uh, this is a particular hemicellulose structure, and when we do the acid hydrolysis, then we get two forms of sugars, arabinose and xylose. We can get these two sugars. So these two sugars are both water soluble. So acid pretreatment is used to make water soluble hemicellulose or water soluble sugars out of hemicellulose. But if the it only occurs when the hydrolysis is complete. If the hydrolysis is partial, then formation of furfuryls can occur, which also inhibit the further reaction. If we need to, if we have formed arabinose, xylose, and furfuryl, or three compounds we have made, then when we will fermentate the sugars, the furfuryl will inhibit. So we need to complete the reaction and form the arabinose and xylose. So now let's move on to the ninth question. Polymers of cellulose and lignocellulosic biomass are interlinked through. So we know that lignocellulosic biomass is composed of lignin, hemicellulose, and cellulose. But in that, particularly, the question is on cellulose. In this cellulose, uh, what type of bonding is there so that the cellulose remains intact? So is it hydrogen bonding, van der Waal, both, or none of the above? So if you will find search for this answer, everybody will say that the correct answer is hydrogen bond, because hydrogen cellulose has very multiple OH in them, and these all the individual monomers of these interact with this hydrogen bonds only. So due to this hydrogen bonding, we the cellulose material has very good strength. So the paper which we use to writing paper, printing paper, all are made up of this cellulose, and the very good strength which it has, it is due to the hydrogen bonding. But the thing is that it also has van der Waal bonds. The fibers inside the cellulose, there is a very long fiber, but inside it has microfibers. So these microfibrils inside have some type of van der Waal forces also. So very small type of force, but it is present there. So the correct answer is A and B. But the major bonding is hydrogen bonds. So this is a typical cellulose, and the dashed line which you see is a type of hydrogen bonds. Every other cellulose is connected to itself with hydrogen bonds. But the microfibers present in them are also connected through van der Waal forces. So both are there. So now let's move on to the 10th question of 2021 assignment. Reduction of particle size of biomass results in increase in reactivity surface area, decrease in crystallinity, increase in degree of polymerization, or both. So first of all, we will consider how what happens when we reduce the particle size. Assume that there is a very large ball and I hammer it continuously to break it into smaller balls. And now I have made very multiple balls out of this very large ball. So what will happen is that the volume will be constant of both. Mass will also be constant. But the thing is that surface area will increase. You see that it has a surface of this, but it has a very large surface area. These balls collectively has very large surface area. It has a surface area here, it has a surface area here. So collective surface area of these small balls are very much large. So when we reduce a particle size, so the surface area increase, therefore increase in reactive surface area is the right answer we can say here. Also sometimes when we do the size reduction very harshly, in case of cellulose, if we have a cellulose fiber and we reduce the size and it forms a rice like structure, a small rice like structure, and then if we will break it again we will get spear like structure. So in this what happens is this fiber is made up of crystalline region and amorphous region. So when we break these fibers, first amorphous region gets break. So amorphous region will get break and crystalline will always be there. So overall the crystalline will be higher in smaller parts. So crystallinity all will increase during the size reduction. So in this, if we look into this way, size decrease in crystallinity will not be the right answer. Hence, NPTEL answer might not be right. But in very few cases, when we reduce this size with the help of any type of acid or any type of very harsh acid such as 70 more than 64 weight percent of H2SO4 if we will use, then this acid will break amorphous region also and crystalline region also, and we will get reduced size, but both crystalline and amorphous part will be broken, both of them will be broken. So in that case a decrease in crystallinity will also be achieved. So it is a very subjective question. The answer can be only A, and A and B both. So it all depends upon on how much extent we go for right size reduction. Are we doing a nominal size reduction or are we doing a extremely size reduction? But if we are doing a lot of if we use some harsh chemicals for this size reduction such as concentrated H2SO4, then the crystallinity will definitely decrease. Therefore the answer for this is both A and B. So this is what fiber look like, and this is what broken fiber will look like if we break these. These fiber collectively will have a large surface area, so the first option was right. And this sphere will also have a large surface area. So, and in both the cases, if the amorphous and crystalline region both are broken, if both of them are broken with the highly concentrated H2SO4, then crystallinity will also decrease. So in this way, size reduction will lead to higher reactive surface area and lower crystallinity. So the past questions of assignment 4 of 2021, I hope that you have understood that, and this will also help you in revising your basic concept. You have done your assignment 4, and but I am just telling these basic concepts because in a different in layman terms and very easy way, so that you can grasp the basics behind it. So Now let's move on to the assignment 4 of 2022. Most of these questions were repeated, so I have removed those repeated questions, and there are only few here. So now let's start with the assignment for 2022 question. The polysaccharide fraction of lignocellulosic biomass, including cellulose and hemicellulose, can be broken down. So lignocellulosic biomass has cellulose and hemicellulose and lignin in it. Third is lignin. But the question here is on polysaccharide. So lignin is not a polysaccharide, therefore lignin is not mentioned in the question. So we are talking only about cellulose and hemicellulose. We know that these are polysaccharides, and if we want to break it, then what will they form? Will it form sugar, amino acid, nucleotide, fatty acid? And we have seen earlier also in this lecture that I have compared cellulose with sugar. The structure was same. The difference was that it is a disaccharide, it is a polysaccharide. And hemicellulose also. When we break the hemicellulose by acid treatment, alkaline treatment, organosol treatment, any kind of treatment, we are just breaking the hemicellulose into monomer sugar. So cellulose and hemicellulose both can be broken down into some type of sugars. So the answer is sugars. And this slide is repeated as the question was same. The monosaccharides forms the disaccharide, and thus if we break these hemicellulose or cellulose, we will get monosaccharides and disaccharide again. If we can combine them, we can also break them in similar form. And hemicellulose also, we have seen that it is made up of pentose and hexose, which are also soluble sugars. Now let's move on to the third question. The composition of lignocellulosic biomass varies with. So we know that composition of lignocellulosic biomass is lignin, hemicellulose, and cellulose. But the composition, the ratio of lignin to hemicellulose, the ratio of cellulose to hemicellulose, this ratio, is it constant or it varies? So the question was that it varies with plant species, age, stage of growth, or all the above. So the correct answer for this is all of the above. What happens is if you take some type of woody plant or non-woody or any kind of leaf, stem, or any other waste biomass, if you take, every plant is a different material. Every plant is also structurally different. So if the structure of the plant is different, if you can feel it, if you wood is hard and plants are non-wood plants are soft, so why would they have similar composition? They all will have different composition. They will have lignin, hemicellulose, and cellulose, but the ratios might be different. Some might have higher cellulose, some might have higher lignin. So it all changes on the plant species. Also, when we compare a single plant, if we look for a eucalyptus tree, a small eucalyptus tree and a large, if we compare these two, uh, if we compare these two, age and stage of growth, I'm taking example of these. So these two will also have different composition of biomasses. It is not constant at every stage. So that's why the answer for this is that all of the above: age, stage of growth, and different plant species. All of the reasons are responsible for the variable composition of lignocellulosic compounds. And sometimes even the soil in which the tree is there is also determines the soil, and climatic changes, climate and soil also determine the composition of lignocellulosic biomass. So answer to this is all of the above. Now, the fourth question, which of the following is a physical form of pre-treatment? Microwave, physical. So the word here which we are looking for is physical. So the answer were microwave, ammonium fiber explosion, steam explosion, or none of the above. So when first time we see this, we think that steam explosion and microwave both might be physical, because in steam also we are giving high pressure. In this we are giving high pressure, and pressure is a physical form. So a first guess will think that microwave and steam explosion both are physical forms of pre-treatment, but no, only microwave is physical form. Steam pre-treatment involves pressure, and it happens in the presence of water. And in during this steam exploration, the lignocellulosic biomass, there is a chemical change in the lignocellulosic biomass. So when there is a type of chemical change during the physical process, it is known as physicochemical. So explosion is a type of physicochemical pre-treatment, and microwave is a physical. It involves only physical treatment. Whereas ammonia fiber explosion is a type of chemical treatment, because it involves the usage of ammonia, which is a chemical. So the answer for this is microwave. That microwave is only the physical form of pre-treatment. So, steam explosion is a physical and chemical both. It involves chemical reactions such as hydrolysis of hemicellulose and formation of inhibitor like furfural. So, there's a chemical reaction. We are forming some types of furfurals which will act as an inhibitor. So, it is a chemical and physical both. Ammonia fiber explosion involves chemical reaction or solvent-based reaction, particularly the use of ammonia. So, it is known as chemical pretreatment. Whereas microwave is a very different thing. The high frequency electromagnetic waves causes the water molecule within the biomass to vibrate very rapidly. So, if you have seen somewhere, if we use microwave to heat food also, next time do one thing that if when you heat the food, for example, Indian cuisine samosa, if you cook that, you will notice that the outer shell of that snack will be cooler, and the inner potatoes will become more hot. So while touching it will be cool, but inner it will be hot, because when we use microwave, high frequency electromagnetic waves goes, and these high frequency electromagnetic waves goes towards only water. If there is no water outside, then the outer part will never heat up. It will only heat where there is a polarity or any kind of water molecule. So the potato, because potato has water in it, a high amount of water, so the water inside the potato will vibrate and will rapidly heat it up. So in this case also, in biomass also, if within the biomass, if there is any type of water present, that water within the biomass will vibrate and generate very large amount of heat, which then further break down the lignin and hemicellulose bond. And by breaking this hemicellulose and lignin bond, cellulose will be more accessible to subsequent enzymatic hydrolysis or any other type of hydrolysis. So microwave is only a way in which only water is targeted, and it is heated by rapidly vibrating the water, rapidly vibrating the molecules of water. So that's why microwave is a physical form of pre-treatment, unlike steam explosion and ammonium fiber explosions. So now let's move on to the sixth question. Now we have seen that what does acid pre-treatment do? You know what is acid pre-treatment? We use the acid to treat the fibers, and we particularly break down the hemicellulose to soluble sugars, and we also dissolve lignin, or and then precipitate it. But what is the main disadvantage of this process? There might be some type of disadvantages. That's why we have gone for alkaline pre-treatment and organosol, microwave, steam explosion. We have seen that we have why we have explored those, because there might be some disadvantage of the acid pretreatment. So what are those? So the first option was corrosive environment of reaction, possible formation of inhibitor, high reaction rates of cellulose and hemicellulose, or both A and B. So first of all, we will go for the word acid. Acid is, what is acid? Acid is we use H2SO4 in this process. We have discussed this. So H2SO4 is very corrosive in nature. So if we cannot use any type of container or any simple containers for the acid pretreatment. If we will use any other metals also, it will corrode the equipment also. So, and the reaction is also very harsh. The environment, it or the due to the sulfuric acid fumes will be corrosive also. So the corrosive environment of the reactions is a disadvantage of the pre-treatment. Also, we have seen that during the formation of pentosan and arabinos, any type of which we make when we break the hemicellulose, then these soluble, sorry, just wait a minute, there's a call coming. Delay. Yes, so when we break the pentosans, when we break this hemicellulose into the soluble sugars, we also sometimes get some other chemicals known as furfuryls, which act as a which act as an inhibitor in further reaction. So if we get the soluble sugar plus furfuryls and then do the fermentation of this, then we cannot do a good fermentation because furfuryl will act as an inhibitor. So this formation of furfuryl is not a good thing. Therefore, possible formation of inhibitors such as furfuryls is also a main disadvantage of the acid pretreatment. The third option was high reaction rate of cellulose and hemicellulose. Yes, it is an advantage, not a disadvantage. So the answer is not C because the question was about disadvantage. Therefore, the answer is A and B only. So first of all, yes, acids are corrosive in nature. Therefore, that the acid pre-treatment has a corrosive disadvantage. And during the acid pre-treatment, the hemicellulose in the lignocellulose is hydrolyzed into monomer sugar such as xylose, arabinose, which can be further converted to fermentation products, which we know this. But sometimes during the acid hydrolysis, furfuryl or hydroxymethyl furfuryls, or shortly HMF, these chemicals get formed, and these chemicals, if present with the xylose and arabinose, will inhibit the microbial growth and fermentation. So this is the major disadvantages: the possibility of formation of furfuryls and hydroxymethyl furfuryls. So these inhibitors also reduce the yield and rate of bioconversion of the resulting sugar stream into biofuels or other value-added products. So you might have remembered this diagram that we can make arabinos and xylose, but sometimes hydrolysis also yield to furfuryls. This is not a good compound. This will act as an inhibitor. So in most cases, what we do is we get the furfuryls extracted after this hydrolysis. So after the hydrolysis, if there are any furfuryls formation, we will extract this also, because these furfuryls can be used to make some other kind of products such as resin or plastic or any other coating material. We can make very different types of material from this furfuryls. So we will just extract it from the arabinos and xylose before fermenting these two sugars. So now let's move on to the eighth question. The main advantages of steam exploration pre-treatment of biomass are, so previous question was about the disadvantage of acid pre-treatment, and this question is about steam explosion pre-treatment and only about the advantages. So first of all, if we go for the word, it has a word steam in it, steam explosion. So we are doing something in high pressure because there is a word explosion, and we are utilizing steam. So we are using water to make steam. So there is a option C, lack of chemical use. If we are only using steam and no type of organic solvent, no acid, no alkaline, no ammonia, nothing we are using. We are just using steam. So lack of chemical use is an advantage. So main advantage of this is less of lack of chemical advantage. Also, the equipment cost or energy cost during this is also very less. So lower energy consumption is an option. And however, if we do the steam explosion pre-treatment for a very high time, then and the temperature inside it is nearly 150 degrees Celsius and above also sometimes. So at this higher temperature, the biomass will degrade. So we cannot use very large time, we will use only very less time. So therefore short residence time or short contact time is also the main advantage of steam explosion pre-treatment. So first of all, the lack of chemicals used in steam explosion pre-treatment is an advantage because it reduces environmental pollution and the cost of pre-treatment. Short residence time is preferred. It is preferred because it reduces the exposure of biomass to high temperature. Because if we will use higher time, then biomass will be subjected to high temperature and high pressure for a very long time, which can lead to unwanted reactions such as degradation of sugar. High temperature and high pressure can degrade the sugars also. So we will only prefer short duration time. And this short duration time will also lead to lower energy cost. That's why lower energy cost, lower chemicals used, and lesser residence time. All three are the major advantage of steam explosion pre-treatments. Now let's move on to the 10th question of assignment 4. The advantages associated with mild acid biomass pre-treatment are. So the past in past we have discussed about acid pre-treatment. Now this question is about mild acid pre-treatment. So the major thing about this is we are talking about less acid. And the question was about disadvantage. It has an advantage. So what it might be the advantage? Low chemical cost. Yes, low chemical cost. Why? Because we are using mild acid. Earlier we were using concentrated H2SO4 for acid hydrolysis, acid pretreatment. Now we are using mild acids only, so low chemical cost. And possibility to use all biomass fraction. This I will explain in the next slide that why there is a possibility. And if we are using less acids, and then the energy demand will also be less. So the answer for this is all of the above. I will explain the third possibility in the next slide. So mild acid pretreatment uses low concentration of acid and mild reaction condition, which result in lower energy demand. So the energy demand is low due to mild reaction condition, and chemical cost is also low when compared to harsher pretreatment methods. So these two are less. It also has the advantage of preserving most of the cellulose content of the biomass, which allow for the possibility of using biomass for subsequent process. What happens is that when we use very harsh chemicals for the biomass, it can sometimes degrade cellulose and hemicellulose. So the degradation will reduce the yield also. But when we are using mild chemicals and mild uh, reaction conditions, then the yield will be higher because there will be no degradation or less degradation. So this less degradation due to mild acid concentration is responsible for preserving most of the cellulose. We can preserve that cellulose content just by using mild acid treatment and mild reaction conditions. Now let's move on to assignment 4 of 2023. Most of the assignment 4 questions of 2023 were from 2021 and 2022. So the only unique questions I have kept here. Rest I have not discussed because those are discussed in 2021 and 2022 only. The pressurized hot water extraction is carried out in the temperature range of. So first of all, it pressurized hot water extraction. I will tell you the answer for this is 150 to 180. This one, and I will explain that when we use these types of temperatures in the next slide. So first, I will tell you about the pressurized hot water. So when we use pressurized hot water, we are applying some kind of pressure to it, and if we are providing some kind of pressure, we can go for nominal temperatures. If pressure is high, we can go for nominal temperature. Why to go for higher temperature? It will degrade the cell biomass. So we can go for nominal temperature when pressure is high. So that ranges from 150 to 180 degrees Celsius. It is used for dissolving pulp process and reduction of hemicellulose content. And if there is another method, liquid hot water process. So in liquid hot water process, there is no pressure. So there is a nominal pressure, but then reaction will not be very good. It will not. It will take a lot of time. So to increase that, we will increase the temperature. We will not use 150 to 180. We will use higher temperatures such as 140 to 230 degrees centigrade. So in case of liquid hot water process, we use higher temperature. In case of pressurized hot water, we use 150 to 180 degrees Celsius temperature. So it's just a balance of pressure and temperature. In one we are using high pressure, nominal temperature. In one we are using nominal pressure and higher temperature. And there is a third also, hydrothermal carbonization. This we will study in next week or subsequent weeks about this. This hydrothermal carbonization requires 180 to 250 degrees centigrade, and it is used to convert biomass into modern carbon materials with specific physicochemical property. It is not used mainly for energy intensive things, but for other modern carbon materials. So this process requires 180 to 250 degrees centigrade temperatures. Which is the main component of hemicellulose in hardwood? Glucuronxylon, galactoglucomannan, arabinoglucoxylon. The, these all are the components of hemicellulose. They all are part of hemicellulose. But the question was that what is the main component? And particularly in hardwood. So in hardwood, glucuronxylon, which is the option A, is the main component. This will not affect the chemistry of the of the pre-treatment. This is just for the information only that the main component of hardwood is glucuronxylon. This is present in a very large quantity, but these two all are also the components. So if the question was what are the component, then all of the above. But the question was what is a major component, so the answer is glucuronxylon. So all are the components of hemicellulose, but the main component of hemicellulose is glucuronxylon, and it is a type of hemicellulose which is a very complex branched polysaccharide and commonly found in hardwood and some non-woody plants. It is composed of main chain of xylose sugar units with occasional side chain of other sugars. So we do not need to go in much deep that what in the chemistry of glucuronxylon, just that it is the major component of hemicellulose in case of food materials. Now the seventh question is in lignin, various monomer units are linked through. So when we look at the various lignin materials, So these are linked through some type of bonds. So this 7 and 4 represent nothing but the bond between OH and the carbon of other. So this bonding is done by which one? Is it seventh carbon or fourth carbon of the ring? So this 7 and 4 represent this, and aryl ether and aryl ester. Is this a ester bond or is an ether bond? So I will explain this here. Lignin is a complex polymer of three main monomers such as paracameral, coniferal alcohol, snapple alcohol. Don't be confused with what are these compounds. Just remember one thing, that they are alcohols. All have OH in it, and these are aromatic. Synapyl, coniferal, or comeral. This means that there is some kind of aromatic compound in it. So these aromatic compounds have carbon in it and OH in it. Then what type of carbon is linked with these OH? So 4 in beta O4 represents C4. So this means that hydroxyl group of phenolic compound is linked to the carbon 4, fourth carbon of the other unit. That's why it is known as beta O4 bond. And it is an aryl ether bond. So uh, and majorly 50 to 60% of the bonds are made up of these. Beta 07 are also present, but in lesser quantity. The major proportion is made up of beta 4 aryl ether bonds. So this is a very complex structure of linen. We do not need to go into it, but the majorly type B, this one type of bond is there. So this one COC, this is known as aryl ether bond. Ether is represented by COC bond. So this is known as ether, and it is a linear. It is connected with the phenols, and here it is single chain, so aryl ether, and OH bond is used to connect these. So that's why it is known as beta O4 bonds. The advantages associated with alkaline industrial pulping process is, so first of all, what is alkaline industrial pulping process? Pulping process is nothing but to break down lignocellulosic biomass into individual products, cellulose, hemicellulose, and lignin, but particularly removing lignin. Removal of lignin and preservation of cellulose with some hemicellulose. So we need to preserve cellulose and hemicellulose and remove the lignin. This is known as pulping. It is done by various other methods such as alkaline pulping, acid pulping, organosolv pulping, and there are mechanical pulping also, and hydrothermal. There are various types of pulpings. So in this we are talking about alkaline pulping. So alkaline pulping involves the usage of NaOH, and after this pulping we can make paper out of biomass. We can to make paper from the biomass, we first need to do pulping. So alkaline pulping is a very old method, and it is used worldwide in most of the industry, paper industries, which you will see uses alkaline pulping methods. It is the most established method. So the answer for this is defined process technology. It is defined. It is a very old method, and everyone knows. Every paper industry uses it. It is a very simple processing, and it has very simple processes and has a short processing time. So therefore, the answer is all of the above. I will explain what is alkaline pulping in block diagrams in later slides. So first of all, it has a short processing time. Alkaline pulping is a relatively fast process which involves high throughput and increased productivity. It is very simple. It involves very less steps, which reduces the complexity in process to make it easier to operate. We can even take the NOH, used NOH, and then recycle it and then again use that NaOH. That alkaline which we are using, we can again use it after using a recovery plant for it. And it is a defined process technology. It is the one of the oldest technology which we are using to make pulp out of the biomasses. So this is a block diagram of what alkaline pulping looks like. So we take a biomass which will act as a raw material and we will put it in a digester. Digester is nothing but it is a type of pressure cooker, and it, if we can compare it, we can compare it with the type of in our household with pressure cookers. And in this we put our biomass in the presence of alkaline, which is also known as cooking liquor, because we need to cook our biomass, and that can be done in the presence of cooking liquor. And this cooking liquor in alkaline uh, pulping is known as NaOH. We use NaOH for the cooking of biomasses in alkaline pulping. So we will use a cooking liquor, we will put it into the digester, and then we will heat it. And inside it, there pressure will be generated, a very high pressure will be generated, and due to that heat and pressure, this cooking liquor will enter into the structure of biomass. It will enter it and burst it. Our If we put some wooden blocks inside it, and NaOH solution will go inside the wood, it will burst the wood and we will get fibers out of it. We'll get very suspended fibers in a very thick liquid, thick black liquid. That's why the now after receiving this black liquid, black suspension, we will send this we will do the extraction of black liquid and then send to chemical recovery plant. This black liquid is nothing but NaOH, but it has NaOH plus lignin and some kind of extractives. So this is known as black liquor. We will take this black liquor and we will send it to chemical recovery plant, in which we will recover the NaOH. We will recover the NaOH and again use it for the cooking as a cooking liquor. So we can use this cooking liquor again and again just by recovering the NaOH. So NaOH is in this. What we have done is we have removed the lignin and extractives, and the fibers which we have now here will be washed with hot water. We will wash it with hot water, and then we will screen it, and then after screening we will get some fluffy type of material which will be fibers in fiber form, and these fibers are cellulose and hemicellulose. So it is what alkaline pulping is nothing but it is a method to convert any kind of lignocellulosic biomass, to convert a lignocellulosic biomass into cellulosic biomass. We need to remove lignin and extractives. We just need cellulose and hemicellulose. It also removes some amount of hemicellulose also. It also removes hemicellulose also. And if we use higher temperature and higher pressure and higher NOH, it can also degrade the cellulose and hemicellulose. So we need to also calculate the amount of NOH required for the pulping. So this is a very proven method and it is used in every paper industry worldwide. Now let's move on to the ninth question. The organosol treatment of lignocellulosic material with the, so this is again a question which was repeated. So yes, organosol treatment will be used to remove lignin and solubilize hemicellulose. Every type of pre-treatment which we are doing only to remove the lignin and solubilizing the hemicellulose. Now Your due date of assignment 5 of 2023 might be near, and that's why I will discuss the assignment 5 of 2021 and 2022. But I will discuss only those assignment which are not repeated in this time. So, assignment 5 of 2021, there was a question that what is the maximum moisture content of biomass that can be used in suspension fire units? So, when we need to when we need a biomass and we need to use it as a suspension fire units, it must have less moisture content because these moisture are not considered as good. So but how much less can we go for? Particularly we go for only 50% of moisture, but maximum we can go for 55 to 65. We this is the highest limit, but ideally we will only go for 50% moisture content. So biomass with higher moisture content may require additional drying process to be suitable for suspension fire. So if it has more than 60 or 65%, if it has more than this much moisture, we may need some other drying process just to reduce the moisture below near to 50 or 55. So, but why it is done? Why we? Okay, some. I'm sole person in it. Shall we discuss in the next meeting request? Okay, okay. So, as Sanjay has okay, so only one participant is there, and you're requesting to discuss in the next. Okay, if you have no issues, we will discuss this assignment 5 in the next meeting. I hope that you have no problem in that. Okay, thank you. Thank you for listening, and I hope that you may have revised your assignment 4 concepts. And next time we will discuss about the assignment 5 questions. Thank you, Sanjay, and we will meet you next week.